In this video lecture, we are going to discuss about the derivatives. We'll try to understand what is this and how we can use this. So I would like to start with a simple example. So let's say there are two workers in some company. So the worker A earns $1 per hour and the worker B earns $2 per hour. What I want is I would like to express the wage of the worker A and the B using some functions and try to sketch this. So if I would try to do this for the first worker, so let's try to understand what kind of function this is. So I'm going to sketch the graph. So here on the x-axis, I'm going to have the time scale. On the y-axis, it's going to be the wage. So the amount of the money the worker earns after 1 hour, it's going to be $1. After 2 hours, it's going to be $2. After 3 hours, it's going to be $3. And after four, it's going to be $4, and so on. So if I would just basically connect all of these points, I'm going to get this kind of curve. Which is simply f of x, let's say, is equal to the x, right? Or y is equal to the x. So I've got all of these points here, 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 here. So at the same time, I would like to express the wage of the worker B. So in order to do this, I'm going to put a couple of points again. So after 1 hour, he's going to earn $2. After 2 hours, he's going to earn $4. After 3 hours, $6, and so on. If I would just connect all of these points, I would get another line, this kind of line. And this function now is going to be g of x is equal to the 2x. Okay? So now there are a couple of questions which I would like to understand. For example, I would like to try to understand how much the worker A has earned between 1 hour and 3 hours. So I would like to try to do this on this example particularly and try to understand this, how we can do this in general for any lines or any curves. So let's try to do this for this example. So here, I've got the 2 points. So this point is going to have the coordinates 1 and 1. This coordinate has the point 3 and 3, right? And if I would like to try to understand how much the worker A has earned, what I have to do is I need to subtract the y coordinates of these points, right? So essentially, I need to get the y coordinate here, the y coordinate here, and the subtraction of the y coordinates of this point is going to tell me the height. So how much this worker has been earned. So it's going to be 3 minus 1, which is going to be $2 between 1 hour and 3 hours. So it's going to be 3 minus 1. It's going to be equal to the 2. Okay? At the same time, I would like to try to understand how much the worker B has earned between this time. So let's say in 1 hour, it's going to be the coordinates 1 and 2. In 3 hours, it's going to be somewhere there. So it was the coordinates 3 and 6, right? So this is going to be the 3 hours there. And the amount of the money the B has earned between 1 hour and 6 hours is going to be equal to this 6 minus 2. So essentially the difference of the y coordinates again. So it's going to be the y coordinates difference. It's going to be somewhere here. It's like 6 minus 2. So the worker B has earned 6 minus 2, $4 between this time, between 1 hour and 3 hours. So you see, so if you would like to try to understand how much your function or curve has been changed, it is just enough to subtract the y coordinates of the 2 points on your line or on your curve. But now what I would like to do is I would like to try to understand how fast the wage of the worker A or B have been changed. How fast? how fast the wage have been changed. The wage have been changed. So, well, in this case, what I have to do is I need to find the difference in the y coordinates and divide this to the difference on the x coordinates. So essentially the difference between 3 and 1. So this is going to be equal to the 2. Okay, for example, so it's going to be delta y divided to the delta x, or let's say delta f of x, in order to express the wage of the worker A. So the delta f of x, it's like how much the y coordinates have been changed. It's like 2. How much the x coordinates have been changed? It's also 2. It's going to be equal to the 1. So what does it mean? It means that the wage, so this is the amount, this is the rate of change of the wage of the worker A per hour. Okay, so which was $1 actually, right? And at the same time, we can try to do this using for the second worker. So if I would like to try to understand how fast the wage of the worker B is going to be changed, it's going to be the delta G of x divided to the delta x. So if you choose this point, for example, and this point, so it's going to be 6 minus 2 divided to the 3 minus 1, which is going to be essentially 2, right? So the rate of change of the wage of the worker B is going to be $2 per hour. Okay, so you see, so for the lines, it doesn't matter which 2 points you're choosing. If you would like to understand how fast the wage have been changed, you just need to find the the ratio between the difference of the y coordinates and the x coordinates of the points. So let us try to do this in general case. So let's say you've got some line like this. If you would like to try to understand how, so let's say this line is expressing some phenomenon, and you would like to try to understand how fast these things are changing, right? Not how much. So in order to do this, you choose the 2 points. So let's say the first point is going to have the coordinates x0, y0. The second point is going to have the coordinates x1 and y1. And if you would like to try to understand how fast the things have been changed, you need to subtract y1 minus y0 and divides this to the x1 minus x0. It's going to tell you how fast your curve, how fast the line is changing. And if you remember, any line has the equation in the form of y is equal to the kx plus b, where we say that a k is the slope of this line, which basically is going to tell you how much rotated, so this line, right? So if this line is rotated more towards the y-axis, it means that it is changing faster. Okay, so we can see this here, right? So this line, the yellow line, it's basically sloped more towards the y-axis, and actually it is changing faster. So if you look to the rate of change of this function, it's equal to the 2, while if you look to the rate of change of the red curve, it's equal to the 1, right? So it's changing faster, and this can be expressed using the slope of the line. So in general, this formula, which is the rate of change of the function, is nothing else as the definition of the slope of the line. So if you would like to try to understand how fast your line is changing, just find the slope. Find the slope. So this is how we are going to quantify the rate of change of the lines using some mathematical terms. So mathematically. So we're going to do this using the slopes. So the problem arises when when we have to deal with the curves. So let's say now I'm going to draw another function. So it's going to be x-axis, y-axis, and let's assume that we are given some function in general, this kind of function, for example. Okay, so let me choose the 2 points on this function. So let me choose this point, for example, here. So it's going to be x0. And let me choose, for example, let me continue this line. So let me choose, for example, this point here was the coordinates x1. So if this curve is given with some function f of x, then the coordinates of the first point is going to be x0 then and f of x0, right? So this is how we are going to find the y coordinates. So usually, so the y coordinates of the points on this curve, along this curve, can be found using this function f of x. You just need to plug the x-axis, x points, into this function in order to find a y. And the coordinates of the second point is x1 and y1, or like f of x1. And now, if I would like to try to understand how fast the curve is changing, I can't really find the slope of the curves because the slopes exist only for the lines. It doesn't exist for the curves. But what I can do is I can try to make a line and find the slope of that line is going to tell me how fast the curve is changing between these 2 points. So let me explain what do I mean. So if I say, hey, how much this curve has been changed between x1 and x0? Say how much the curve has changed. The curve has changed between x0 and x1. So what you say, hey, so it is, so you look up to the height of the 2 points and you say that, hey, they have been changed between f of x1 minus f of x0. So this is how much they have been changed, right? So if you look to the heights, so let me try to draw this. So it's going to be the height 1. So this is the f of x1. This is the height 2. This is f of x0. This is f of x1, right? If you subtract, it's going to tell you how much your curve has been changed. So actually it's decreased, so that's why you're going to get the negative value here. Now, if I say, hey, how fast this curve has been changed, how fast the curve has changed. What you're going to do is you are going to basically connect this with the slope of a line. So essentially, you're going to find a difference on the y-axis, and you're going to divide this as a difference on the x-axis. Okay? So essentially, geometrically, it's going to look like this. So you are going to basically connect these 2 points with some line, and by finding the slope of this line, it's going to tell you how fast your curve has been changed between these 2 points. The slope is going to be f of x1 minus f of x0 divided as x1 minus x0. So this is how we are going to find the rate of change of the curve between these 2 points. Now let's change the problem a little bit. So what I want is now I would like to try to understand how fast the curve is being changed exactly in 1 point. So let's say it's going to be x, this is the y. Again, we're given some curve, something like this. So it's going to be f of x. So previously, if you were given the line, so the rate of change of the curve of the line at any point are going to be the same because the slope of the line is the same. Here, the problem is depending on so which 2 points you're choosing, you're going to get the different slopes, right? For example, if you choose x1 and x0, the slope of the lines through these 2 points is going to be 1 value. And if you choose another point, for example, let's choose this point here, it's going to be x2 point. Then the slope of the line passing through these 2 points is going to be different, right? So let's assume that this is K1, this is K0, the slopes of the two lines, and they are different. While for the lines, it was the same. So you see, so as you choose the different points along this curve, so the rate of change might be different. So now the problem is, I would like to choose one point, exactly one point on this curve. So let's say this point is going to be x0. So if the function is given as y is equal to the f of x, then the coordinates of this point is going to be equal to x0, x0, and f of x0. Okay? So I would like to know how how fast the curve is changing. The curve is changing exactly at this point at x0. Okay, so do you remember previously, if I say, hey, could you please tell me how fast the curve is changing between x0 and x1, or x0 and x2, between the 2 points, what we did is we made a line and we found the slope of that line. And that would mean the rate of change of the curve between these 2 points. Now, if you're just given one point, it is difficult to find the rate of the change of the curve exactly at that point, right? So the idea would be to just choose another point which is going to be really close to this and try to approximate the rate of change by finding the slope of that line. Okay, so let's try to do this. So this is our x0 point. What I want is I would like to choose another point here really close to this point. So let's say it's going to be x1, which is x0 plus delta x. Okay? So this point is going to have the coordinates x1 and f of x1. Okay? So if I would like to try to understand how fast my curve is changing at the x0, I'm going to choose another point artificially in order to make the line, because I cannot make the line just using one point, right? So let me make the line between these 2 points. It's going to be this kind of line, and I can find the slope of this line, right? So the slope of this line is going to be like this. So the slope of this line is going to be f of x1 minus f of x0 divided to the x1 minus x0, right? But is it the solution? So, I mean, is it the rate of change of the function exactly at this point x0? No, it's just an approximation, right? So it's like approximation. So we say that, hey, approximately it's going to be like this. Because we just had the one point, right? So how we can improve our approximation? So we can improve this by just making this distance between these 2 points, which is delta x, really small, right? So the idea would be, so if I would like to try to understand how fast the curve is changing, so then just like find the slope of the line between 2 points which are really close to each other. So let's say f of x1 minus f of x0 divided to the x1 minus x0. So let's substitute the definition of the x1 into here. It's going to be f of x0 plus delta x minus f of x0 divided to, if you subtract x0 from the x1, it's going to be simply delta x. Okay, so this is the slope of the line between the 2 points on the curve, which are really close to each other. Okay, so approximately it's going to be like this. If I would like to try to understand what is this exactly, what I have to do is I need to get the second point, right, x1, really close to the x0. So I can do this by finding so-called limit of this ratio when the delta x tends to go to the 0. Okay, this is going to be exactly the rate of change of the curve at this point, x0. So let me draw this curve again one more time here. So that's my curve. So that's my point x0. So if I would like to try to know what is the rate of change exactly at this point, I'm going to get this kind of line. So the slope of this line is going to be this limit. So this is going to be the slope of this line, and I'm going to call this line as the tangent line. So this word tangent is coming from the word so from the Greek word which means touch, and this line is just touching the curve, okay? And it's going to tell us how fast the curve is changing exactly in one point, okay? So we can express this using the derivatives. And the slope of this line can be found by finding the limit. And this is actually nothing else as the derivative of this curve. Okay, so we are going to define the derivative of this curve at this point x0 as the limit of f of x0 plus delta x minus f of x0 divided to the delta x when delta x goes to the 0. And this is the definition of the derivative. It means the rate of change of the curve in one point, exactly in this point. So let's try to write this down. What does it mean? So this is the rate of change of the curve y is equal to the f of x at this point x0, or x0 f of x0. Well, the derivatives are a really powerful tool in order to make the analysis of the curves in many different areas. And as we are going to go through the lectures, we will try to understand and reveal the features of the derivatives and its applications into the different fields. So far, this is the definition of the derivative, geometric definition, and a physical meaning of the derivatives. So I hope that this was helpful for you.